First partial project by Gina Matarolo and Mauricio Galvan. The first problem we're going to be answering is number 1b, finding limits through piecewise functions. So the piecewise function we have states that every number that is smaller than -2 is going to be plugged in the function x plus 3, and every number that is bigger than -2 is going to be plugged in the function absolute value of x minus 1. With this piecewise function, we are asked to find 3 different limits, and for that, we graphed the function in Photomath because it was the easiest tool we had. To find the first limit, we're going to be zooming in on the graph to see what happens as x approaches 4. Since this part of the graph is linear, we can already see that the limit as x approaches 4 is going to exist, but to be sure, we're going to evaluate the limit from the left side first. And by looking at the graph, we can know that it's approximately 2.9, and then we're going to evaluate the limit as x approaches 4 from the right side, which is going to be approximately 3.01. Since both limits have approximately the same answer, we can already say that the limit as x approaches 4 is going to be 3. To find the next limit, we're going to be doing the exact same thing. We're going to be zooming in on the graph, but this time we're just going to look on the left side of the graph since it's specified, and we can say that it's 0.99, which is almost 1. And for the last one, the limit as x approaches -2, we already had the answer as x approaches -2 from the left side from the previous answer, which is 0.99. So what's left is just to evaluate the right side. Which is going to be 0.99. And since both answers are the same, we can say that the limit as x approaches -2 is 1. The next problem we're going to be answering is number 24. Evaluate the following limits. And this is the limit as x approaches 1 from the right side. And the function is 2x plus 3 over x minus 1. So the first thing we're going to do is plug in a number that's bigger than 1, for example 1.01, in every x that we have in the function. Next, we're just going to multiply, add, subtract everything that we have. So 2 times 1.01 plus 3 gives you 5.02, and 1.01 minus 1 gives you 0.01, and that, if divided, gives you positive 0.502. We can say that since the answer is positive, every value that you add that's bigger than 1 is going to give you a positive number, and for that the answer is positive infinity. And the last problem we're going to be answering is finding the slope of the tangent line, which is number 87. And to find the slope, we're going to be using derivatives. So the function of problem 87 is 8 over square root of x, and the x that's given is 4. The first step to finding the derivative is rewriting. So instead of having 8 over square root of x, we're going to write 8 times x to the -1/2. Then, by using the power rule, we're going to multiply the exponent, -1/2 times 8 times x to the -1/2, and then we're going to subtract 1, which is the same as 2 over 2. And that gives you -8 over 2 times x to the -3 over 2. That gives you -4 times x to the -3 over 2, but we're going to rewrite it so that we don't have negative exponents to -4 over square root of x cubed. And the last step is finding the slope, and that is going to be negative 4 over square root of 4 cubed, which is negative 4 over 8, and that gives you negative 1/2.